In this lesson, we'll begin preparing the essential groundwork for building creation. We'll need to approach this using a couple of steps. The method we'll use to create our buildings involves applying a Boolean to slice shapes from city blocks, which will serve as foundations for buildings. So when we observe this bottom left city block here, the shapes will resemble something like this. Once again, sorry for my rough and sketchy drawings here. We're going to create something similar to this, where some forms might vary in size. Something a bit like that. We'll later extrude each of these, and then add instances like windows, doors, rooftops, and more onto them. To start removing these shapes, we'll need a cutter object containing a layout of all these kinds of shapes we'll want to randomize. But we don't want to manually model this cutter and import it into the geometry nodes setup. I want to handle everything procedurally, just like we've done with the rest of the city layout so far. So the focus in this lesson will be crafting that cutter object. But before creating the cutter, I want to do what we did at the start when we set up our roads. It's simply to add a few parameters to the modifier panel that we'll later need for our buildings. I'm not adding every one just yet since there'll be quite a lot, but we'll include a few to begin. So to start, we'll add a new panel and give it a name. Let's call it Building Settings. I'll make sure that my caps lock is on. Inside our Building Settings panel, enable the toggle. It's going to be an integer. Set it to a single value and turn off the attributes toggle. I'm going to call this Building Layout Series. This is going to serve as a seed value so that we can randomize the layout of our cutter to generate random building shapes and arrangements. I'm also going to add another input. I'm going to keep it as a float, but I'll set the subtype to factor. We'll set a minimum of 0 and a maximum of 1 and leave it as a single value. So now we get a slider between 0 and 1 on our modifier panel. And this will control our parks amount. Because as we begin cutting these shapes, I don't want all of them to become buildings. Some of them should be turned into parks where we can instance trees. Let's begin building the first of our node groups for the buildings. We're going to need the interior curves from our city blocks. So I'll drag out from the reroutes of the city block base. I created a second one and used the make group option to put it into its own node group, just like we've done throughout this entire course. Then I renamed the inputs and the outputs. Our input will be named Curve Inside. For outputs, we'll begin with one named Building Curve Instance. That name might change later, and we'll also add more outputs as needed. But just for now, as we begin creating the cutter, this will not matter that much, because for the cutter, we won't use any of these inputs anyway. The method we'll use to make our cutter is to first generate planes, or grids directly inside geometry nodes. So let's add a grid node and reduce the light segments on it. What we are going to do is instance a number of these onto some points. Then, using the new matrix transform nodes available in Blender version 4.2 and above, we'll arrange them into formations that accumulate along one axis. If that sounds a little confusing, it should become clearer soon. I'm not going to go into full depth on the new matrix nodes because they are fairly complex. Matrices can become confusing very quickly. It's enough to say that their inclusion in version 4.2 is quite exciting and opens up new creative possibilities for technical artists. So we'll begin with our grid and make it a 2 by 2 grid. So basically it will be a plane. What's important here is that its size is exactly 1 meter by 1 meter. This is key for how these objects will be distributed and shifted. I'll also add a set position node and move the object by 0.5 along both the X and Y axes. Again, this is important because of how these will be distributed. We need to make sure that they align properly to both the X and Y axes. Good. Use instance on points. This will become our instance geometry. So let's connect this into our instance input. Then we'll add a points node. Here we can set the number of points we want to use. When we look at the spreadsheet, we can see there's now one instance listed. Increasing the count raises the number of instances is being generated. But of course, they will all be placed directly on top of each other visually, so we won't see any change in the 3D viewport. Let's start with a value of 25. This is a value we might want to control procedurally or parameterize outside of this node group. So the first thing I'll do now is duplicate the group input. Take the count value and expose it to the outer level of the group. I'll rename this to building cutter size. And next, we'll take our instances and shift them using the set instance transform node. And in this, you'll see a socket type that we haven't used yet in this course. It's that kind of pinkish-purple transport socket, which tells us this is a matrix input for our transformation. To build the matrix, we'll go to Utilities Matrix and use the Combine Transform node. What this does is take the 3 key parts of a transformation: translation, rotation, and scale, and merge them into one transformation matrix. Matrices can get confusing quickly, so I won't break down every detail of how this works. Instead, we'll use it together with the Accumulate field node, which gives us a running total of values. Normally, this node works with floats or vectors, but with the new matrix nodes, we can now set it to use a transformation matrix. So switch the type to transform. And we'll apply this to our instances. Let's connect the transform into the value input. We'll use the trailing value, which gives a running total that starts at 0. If you hover your mouse over the socket, you'll see a tooltip explaining it. You have the running total starting from 0, while the leading option begins from the first value, and the total is, of course, the complete total, pretty self-explanatory. Let's take the trailing value and plug it into the transform socket. Now, if I begin increasing one of the transform values here, you'll see what effect this has. So if I raise the x value, each of the instance is moved along that axis. It behaves similarly to an array, like the array modifier. If I set the value to 2, each instance is offset by 2 units, and the next one continues from the previous position. Now, what values can we set for our translation or offset? This will be used to determine the x-axis sizes of our buildings. The y-axis sizes will be handled separately. First, let's add a combine XYZ node. Let's plug it in here. Right now, everything snaps back into place because there's nothing on the x value. Let's use a random value node to generate a number between a minimum and a maximum. We'll have a seed input that allows us to randomize these values. This will let us define how large we want our buildings to be. For now, I'll set the range between 20 and 40. But of course, this could be turned into a parameter and exposed outside the group if needed. Let's plug that random value into the x input. Now all the instances are offset by different amounts. But the scale is not right yet. They are still 1 by 1 planes. To fix this, we'll scale the instances. Let's duplicate the combine x, y, z node. Set the y and z values to 1, so we do not flatten the geometry. Plug that into the scale input. Now we have random scaling along the x-axis for all of our buildings. I'll raise the y value here a bit so we can see the result more clearly. As I change the seed value in the random value node, we get a different distribution for the buildings. Now that we have this working along the x-axis, we're going to wrap everything into a repeat. This means we can perform this operation multiple times to generate instance is laid out along the x-axis. Instead of having a group of single planes here, we'll end up with a number of instance layouts, or rows, which we can then accumulate along the y-axis. Just like we did along the x. To do this, we first need to convert all 25 of these instances into a single instance. So we're going to use geometry to instance. That turns everything into one instance. Then we'll wrap this inside a repeat. So we're going to need a repeat node. And if we look at it, it's very similar to the for each loops we've been using. The only difference is that we don't have a separation of elements. Or what happens is that you plug some geometry in. It comes in through here, and then only outputs whatever is being output here. Feedback through to the input on the next iteration. And we can set how many times we want this to happen. So what we're going to do here is take the output of our repeat. So plug our instances into this. And all we're going to do is join the outputs with the inputs. So if I add a join geometry node, there we go, and plug the inputs in here. As I increase my iterations, we're going to get multiple instances of the same thing now being piped in. But of course, they are the exact same thing, which we don't want. We want each of the rows to have a different seed value. So what we can do is take the iteration number, add a value to it, and use that to control the seed. Plug that into the seed input. Now every iteration will use a different seed. Let's take that seed value, and first we need to reuse the building cutter size that we use for how many times we iterated along the x-axis. We'll use that same number for our repeat count on the y-axis. Now take the seed input and expose it outside the group. Let's call this building seed layouts and change it to an integer. Then return to the outer level of the group. And we need to rename this. First, we might as well rename our nodes as building cuts. For the second group input, we'll connect the building layout seed through to here. Now, as we change the building seed layout, we're going to get different variations in these instances. You can kind of see them shifting slightly. To offset these on the y-axis, we just need to duplicate all of the instance transform nodes. I'm just going to reset the combine x, y, z value back to 1. So let's duplicate the random value and add node for the seed, the combine x, y, z, accumulate, set instance transform, scale instances, and duplicate the other combine x, y, z, node 2. We just need to change the inputs so that it works on the y-axis instead of the x. So let's plug the random values into our y-axis. And make sure to set the x scale back to 1. We can take the building seed layout from the group inputs and connect it into the seed input of the new random value, a node. Then take the output from the repeat node and plug it into the second set instance transform node. Now, when I view the output, we can see that we basically have a grid. And as I adjust the seed value for the layout, the size and distribution of the buildings change, which is exactly the result we want. The only issue now is that all of these are packed tightly together. Ideally, we want to add a bit of buffer space between them. To do that, take the output from the random value node and add a value to it, let's say 2. Do the same for the x-axis. So we'll add 2 there as well. Now we have visible gaps between the buildings. This is also a value you could make procedural or expose as a parameter if needed. Finally, for this lesson, let's select all of these nodes. I'm going to frame everything using F4 and place them into a frame. I'll rename the frame to building cutter. Then I'll go up to the node group level. So press A to select everything. And in the next lesson, we'll use this building cutter as a boolean to subtract curves from our city base inside the city blocks.